So anyway, Gwen, welcome.
Hello.
Please step into the studio. We spoke a little bit before, and my summary out of that talk was your role, and you are the guy taking all these innovations and cooperative driving and cars talking to cars from the academic research table into the real physical world.
Yeah, exactly. Now that's our goal, and that's, I think, the next step in cooperative mobility is what you've seen in like last years. Yeah. Is that there have been a lot of studies on the effects of cooperative mobility
and for the people, I don't assume, but for the people who don't know, cooperative driving or mobility, in a nutshell, what is that?
It means basically that vehicles can talk with each other. So they tell where they are, how fast they are driving, how fast they are braking, how fast they are accelerating, if they encounter rain or slippery roads. And they can communicate that to each other or to the infrastructure, and also the other way around. So if you have now the variable message signs, with that say, for example, now you can only drive 70 on this road instead of 130, then that information can actually also be broadcasted through Wi-Fi P. It's a certain Wi-Fi standard that we all have in our routers at home, but then dedicated for the automotive industry. Okay. And then this car knows from the infrastructure that, for example, a certain speed limit is valid, or that there are roadworks and that it has to be cautious. Yeah.
So the core here is the communication between vehicles and between vehicles and infrastructure.
Exactly. Yeah.
Now, where are we? What is where are we in the now?
Yeah, I think in the past we have seen that there has been a lot of studies that prove what this technology can bring to society. Yeah. So it enables much safer cars because they know that there is a traffic jam coming ahead, so they can slow down. Exactly. So it's much safer. Yeah. It reduces the emissions because also you can anticipate much further. I mean, you as a driver can look maybe 3-4 cars ahead of you. Yeah. But if you have wireless connectivity, you can maybe see 1 kilometer in front of you. Yeah. So you can also reduce the emissions. Also in a city, for example, if the car talks to the traffic light and knows that the traffic light is still another 30 seconds on red, it can shut down the engine because there's no need to have the engine on. Those type of things are the cooperative things. Yeah. In the past, we have shown in all kinds of studies that brings all kinds of these effects to society. So less casualties, less emissions, and less traffic jams. Right? Yeah. But now we are at the stage that the technology is proven, the results are proven, but now we have to bring it to the real world. Yeah. We have to bring it from 100 cars to tens of thousands of cars. So that's the next step that we are going to do in the next couple of years.
And that is something you are involved in, right?
Yeah, I mean, my company is typically involved in the testing of these equipment, so make sure that everything works and that all the different parties that play a role in this field, all the different companies that bring hardware and software, that we make sure as a test facility that all these things work together. Yeah. So we can certify that, for example.
And then we take it out into the physical road. What does that look like?
Now, what it looks like is that we have in Helmond, we have a dedicated test facility that has an abundance of sensors at the road. Yeah. There you can really test if everything works fine, and as soon as that is tested, you bring it to the next level. But the next level is another road, typically. Yeah. And there you do not have the same infrastructure. You do not have every 100 meters a communication station or a sensor, but you have it every kilometer, for example. So, so you first need to test it in a very special environment, a kind of lab, and then you bring it to the real world where you then do, also still testing, but then in a much larger scale, where also the effects will be immediately visible.
And what kind of in-car technologies are currently entering that phase of large-scale testing? What can we expect soon to see in the real world?
Now there is one project between the Netherlands, Germany and Austria, which is called the ITS Corridor. Yeah. That brings the first application that they bring live there is a roadworks warning application. So
when you talk about application, this is like a smartphone application or something in the car?
It can be a smartphone application, but it can also be a built-in car.
Exactly, in the car systems.
That depends. I mean, the governments are now investing in the infrastructure, And as soon as that infrastructure is there, the automotive industry has already said that as soon as there are applications, that they will also bring that technology in their cars. Yeah.
Okay, that's
so because otherwise you have the chicken and egg problem. And now you, the government invests in the infrastructure, and then the automotive industry will invest in to bring it into the car.
Okay. So this corridor, how does it work?
Yeah, so the road works, so you have to understand that, for example, the arrow that you currently see go to the left because this lane is closed. That vehicle that is standing there will have an emitter, which is sending out that same information, but then over the air, that the left lane is closed, for example, and then you will receive that information in your car already 1 or 2 kilometers ahead, such that you know it before you basically see the vehicle. Now that makes it also much more safe. And the real good thing is that the exact location is always accurate because the emitter is sitting on the roadworks device. So as soon as that roadworks device leaves the motorway, automatically the signal is gone as well. So
we get better information and we get real-time information.
More accurate, yeah.
And how does this because a corridor kind of implies that there is like a stretch of where I will never be in congestion anymore, or what is happening along the corridor?
Now this is the first step towards
application.
So this is the first application, but more and more will soon follow. And what the Netherlands, Germany, and Austria now have agreed to is that this corridor will be enabled with all the infrastructure that's necessary to make this possible, and then new applications will arise, and that can be, for example, platooning. So that is cars that kind of road trains, cars that follow each other very closely.
Talking a lot about it. You think that's close for real-world application?
It's not going to happen in the next year, but I see the first steps for example, for trucks. We see a lot of interest from Dutch companies. The Netherlands is very big in logistics, and there is quite some interest from Dutch logistic companies to do platooning from the Netherlands, for example, the Rotterdam harbor to Germany, because it saves them fuel. Because if you can have a road train, your truck has much less resistance, fuel, and the truck driver. If basically the first truck driver needs to drive, and the other truck drivers can maybe sleep.
Exactly. So you're more efficient in your workforce.
Exactly.
Now we've been hearing a couple of things you talk about. If I know the traffic light is red, I can slow down early. If I know there's a lane closed, I can. This is all about in-car anticipation on a fixed infrastructure.
Yes.
Now the other side of the industry is also developing smart infrastructure called roadside applications, right? I was earlier today in a seminar. Is it possible that these things become conflicting, right? If the traffic light waits until it goes red, until the latest red cars go through, then the car gets confused because it was supposed to stop. Or what's your view on that, roadside versus in-car?
No, I think these two are very connected, and they need to give a coherent message. So if you have the message signs that give you visual information, it should be in line with the information that is broadcasted over the air. That's one thing. The other thing is also that the data that is being broadcasted is real time.
Yeah.
So, for example, in the Netherlands, you have a lot of dynamic traffic lights. So they broadcast, I will go green in 30 seconds, but basically then something might happen. An emergency vehicle comes from the right, and then the system decides to stay longer on red because this vehicle needs to pass. But it in real time it updates then the time to green.
But are you then saying that we need some kind of monstrous master system which then controls the traffic lights and all the in-car systems? And
no. It's being set up as a kind of organic system. So the vehicles talk to the infrastructure, but they make their own decisions.
Okay.
So it's not that there is some some
big
central
puppet
entity
master.
that decides, okay, that car has to slow down. That it's more about providing the information such that vehicles can decide themselves much better.
That's a nice viewpoint. Yeah. Gerry, do I see that we have a question from the online audience?
Exactly, there's a question. It is lots of infrastructure issues with smart mobility. Sorry, start over again. There
Who's
is
asking the question? Yeah.
Yeah, I can't see.
Okay.
It's
An
a
anonymous
guest
guest.
8177.
Yes.
Lots of infrastructure issues with smart mobility implementation. How long before there is a critical mass, and in what application area?
Yeah, of course. The network effect, right? This only works if everybody participates.
Yeah. No, that's exactly why the governments are currently investing so much money, because you need indeed to have that critical mass. To make it happen. First on the infrastructure, but also in the vehicles. I mean, if you have the only vehicle that is talking with nobody,
it's
not
like
going
the
to
only
work.
one having a fax, right? You
but
can
that's why we do these deployment strategies. It's being subsidized by the governments. It brings the critical mass further and further. So in the Netherlands, in the next coming years, there will be tens of thousands of cars being equipped with these vehicles, such that when the first cars are commercially on the market and you will buy one, you have tens of thousands of cars
already
to
there.
Yeah,
exactly. Cool. And I think I don't know what's your view on that, but the obviously flow problems often exist only by a couple of percentage over demand, right? Yeah. So if you could only top the top off, it could already be solved.
Yeah, that is what the studies have shown in the past. Is that a lot of, actually about 20% of the traffic jams in the Netherlands are what we call shockwave traffic jams or ghost traffic jams.
Phantom traffic jams, I think.
Phantom traffic jams. So they do exist, they are real traffic jams, but there's no particular reason for them to be there. And the most important reason is that it is very busy on the road, and that a sudden braking from one vehicle can actually cause a traffic jam a couple of minutes later, a couple of kilometers further on, because you get the harmonica effect. Those type of traffic jams can be solved or at least reduced significantly with this type of technology, because you can anticipate like a kilometer further on. So you see
actually battle the harmonica.
So the car knows that there is some braking ahead. It just reduces the throttle a little bit. You might not even maybe notice as a driver, but it goes from 100 kilometers to 95 for a couple of minutes, and then the shockwave is being damped, and then everything goes smooth again.
All right, good. Well, Gwen, thank you very much for sharing your views here with us at InterTraffic Live. We're about to go to the theater. I hope you'll join us right there, and
absolutely.
We'll see the project that is taking place in Brabant. Thank you very much.
Okay, thank you.